Hi. In this video I am going to show you how to make a frequency distribution table. A frequency distribution takes a disorganized set of scores and places them in order. This means that a frequency distribution involves organizing a data set with unorganized scores into an ordered format. By organizing the scores, a frequency distribution provides a clearer representation of the data set. A frequency distribution table allows researchers to see at a glance the entire set of scores. By looking at the frequency distribution table, the researcher can gain an overview of the data set without having to examine each individual data point. A frequency distribution generally provides an organized picture of the data. When you create a frequency distribution, you are structuring the information in a systematic and orderly manner. Organizing the data provides clarity, pattern identification, and comparisons. In addition, a frequency distribution table allows researchers to see the location of any individual score relative to all of the other scores in the data set. This simply means that by examining a frequency distribution, they can establish where a specific score stands in comparison to the entire set of scores. The ability to gauge the location of individual scores enhances the interpretability and the analytical value of the data. Therefore, a frequency distribution is an organized tabulation of the number of individuals located in each category on the scale of measurement. Generally, we have two types of frequency distribution tables. The first one is an ungrouped frequency distribution table, and the second one is a grouped frequency distribution table. We will begin by first looking at an ungrouped frequency distribution table. An ungrouped frequency distribution table is a tabular representation of raw data that displays the number of occurrences of each individual value in the dataset. This is contrast to a grouped frequency distribution where values are grouped into intervals or classes. An ungrouped frequency distribution deals with each distinct data separately. Here is a basic structure of an ungrouped frequency distribution table. As depicted, the table is made up of two columns. The first column represents the values or scores denoted as X. The second column represents the frequency of each value. Let's use a practical example to help you comprehend more. The following set of 20 scores was obtained from a 10-point statistics quiz as illustrated on the table below. We will organize these scores by constructing a frequency distribution table. The first step is identifying the highest and lowest score. In this case, our highest value is 10 and our smallest value is 4. After identifying the highest and lowest value, make a table with two columns. The first column of the table lists the values from highs, 10, to lowest, 4. Notice that all of the possible values are listed in the table. For example, no one had a score of 5, but this value is included. The second column of the table represents the frequency associated with each value. For example, 2 people had scores of 10, so there is 2 in the frequency column beside the score 10. You also should notice that the frequencies can be used to find the total number of scores in the distribution. By adding up the frequencies, you obtain the total number of individuals. Next, I am going to show you how to make a grouped frequency distribution table. A grouped frequency distribution table organizes a set of data into groups or intervals, presenting the frequency of observations within each interval. This method is particularly useful when dealing with large datasets. When a set of data covers a wide range of values, it is unreasonable to list all the individual scores in a frequency distribution table. Consider, for example, a set of exam scores that range from a low of X is equal to 41 to a high of X is equal to 96. These scores cover a range of more than 50 points. Remember, the purpose for constructing a table is to obtain a relatively simple, organized picture of the data. The result is called a grouped frequency distribution table because we are presenting groups of scores rather than individual values. The groups or intervals are called class intervals. Class intervals are the ranges or groups into which a set of continuous data is divided for the purpose of creating a grouped frequency distribution. For example, if you have a dataset of ages 0 to 9, 10 to 19, 20 to 29, and so on, each range, for example 0 to 9, is a class interval. A class interval consists of a lower class limit and an upper class limit. The lower class limit is the smallest value that can belong to a particular class interval. For example, in the class interval 10 to 19, 10 is the lower class limit. The upper class limit is the largest value that can belong to a particular class interval. In the class interval 10 to 19, 19 is our upper class limit. Let's move ahead and look at how we can come up with one. We will use an example to help you understand. The following set of scores was obtained from a statistics quiz. The scores cover a wide range from low x is equal to 15 and high x is equal to 48. We will use a grouped frequency distribution to summarize this large data set in a more manageable form. The first step is to identify the largest and smallest value and then find the range. The range is calculated by subtracting the smallest value from the largest value. In this case, our largest value is 48 and our smallest value is 15. Therefore, our range is 33. The next step is to calculate the approximate group size by dividing the range by how many groups you would like and round off to the nearest convenient number. Our range is 33 and our preferred group size is 5. We divide 33 by 5 to get 6.6. We then round it off to 7. The next step is to pick a starting value that is less than or equal to the smallest value. Try to make it a multiple of the group size. Our smallest value is 15 and the value that is equal and less than 15 and a multiple of 7 is 14. Therefore, our starting value will be 14. The next step is to calculate the lists of groups. We must go up to or past the largest value. Starting from 14 with our group size 7, we get 14, 21, 28, 35, 42 and 49. The first class interval will be 14 to 20. This is because our group size is 7. The second interval is 21 to 27 and so on as illustrated in the table below. Finally, make a tally mark for each data entry in the appropriate class. For instance, the data entry 36 is in the class 35 to 41, so make a tally in that class. Continue until you have made a tally mark for each of the entries.